Different people from different backgrounds in the world of mathematics have chosen to express fractions in different styles. Whichever style that works for the person, he uses it. But one thing is very clear. Men have come to invent different styles of writing fractions. Tell me, which one is bigger between 0.5 and 1 over 2? If you think carefully, you will get the answer. But until then, let me assure you that the two of them are just the same. They are just different styles of writing the same number. That takes us to lesson objective number 4, and that is notations of fractions. In this section, we learn different ways people have adopted to present magnitudes of fractions. 0.5 and 1 over 2 being the same are different notations of the same fraction. Please, listen to me carefully as I explain different ways people have chosen to express their fractions. Again, it is notations of fractions. In this section, we learn notations of fraction. By notations of fraction, I mean different forms people choose to write fraction. Permit me to use these 3 fractions to explain what I mean by notations of fractions. 1 over 2, 5 over 10, and 50 over 100. In each case, we know that a number of portions were picked from existing total number of portions. 1 picked out of 2, 5 picked out of 10, 50 picked out of 100. Please tell me, are these fractions different in magnitudes, or are they just different ways of expressing one fraction? Certainly, if you divide one thing into 2 and pick 1, the size of what you have picked is the same. If you divide the same thing into 10 and pick 5, or divide the same thing into 100 and pick 15. Therefore, you can agree with me and should agree that all these 3 fractions are just the same fraction expressed in 3 ways. Let me present a situation. Consider this circle. This circle represents an orange. Just imagine that this orange is to be divided into a number of portions for people to share from. Don't forget that in history, at a point in history, gifts of nature became so scarce and difficult to get, and people began to share things. Till today, things are still scarce, and people still experience sharing one orange among themselves. Now, just imagine that this orange is to be shared between 2 persons. How do you place your knife if you're the one to share it? That is easy enough. If you break it into 2, what is the size of one person's own share? What if you break it into 7? What is the size of one person's share? What if you break it into 10? What is the size of one person's share? Let me outline them. Now, this is the outline of one person's share in each case. If you break it into 2, one person's share is 1 over 2. When broken into 7, one person's share is 1 over 7. When broken into 10, one person's share is 1 over 10. Now ask, which of these fractions here represents the easiest process of division and sharing? That is, dividing something into 2 and sharing from it, into 7 and sharing from it, into 10 and sharing from it. Which of them is the most difficult and which of them is the easiest? You can agree with me that the easiest is this, followed by this one. The most difficult is to divide something into 7. Dividing this orange into 7 is the most difficult of these 3 possibilities. At a time in history, people who had to divide something into 7 among themselves to be shared among them discovered that there was a better way, but inaccurate way sometimes, of doing it. In effort to minimize the work involved in breaking this orange, for instance, into 7, they took a decision. What is that? In fact, you can see it with them that it is difficult to use your knife and divide this orange into 7 equal portions. If it is 2, you can do it. If it is 10, though a little difficult, you can still do it. But it is quite difficult to place your knife across this orange and break it into 7 equal portions. When this challenge was met, they took a decision. They said, even if what we are going to get in sharing will not be accurate, that is, that our share will be less than what we should get by a small quantity, we can do with it instead of suffering ourselves to divide one thing into such odd number of portions, which is 7. They now decided to pick 10 as the number of portions to divide something into. These 7 persons would then divide this orange into 10 and begin to pick from those 10. After picking from those 10, we know that we still have 3 portions remaining. In this section, we're not going to be concerned with how to further divide those 3 portions. We're only concerned with the fact that those 3 portions that are remaining will be repeatedly divided into 10 portions each. And then the 7 persons will keep on picking until they are tired of picking, or they pick and the number of portions just become equal to the number that 7 persons can divide without remainder. Until then, just know that 7 persons took decision to divide this orange, for instance, into 10 and pick from the 10. When they get tired of picking, they can quit the picking. But by all means, they have gotten a share, inaccurate share, but they were able to endure the inaccuracy of that share, but not endure the difficulty of breaking this into 7 equal portions. As a result, it became popular for people who were below 10 to divide something into 10 and pick from those 10. That is how 5/10, for instance, came to be, meaning dividing something into 2 and picking 1. It's just like breaking that same thing into 10 and picking 5 from it. Therefore, this is just another way of doing this. The question is, what if the people who are dividing, or who will share the portions after division, are more than 10? In that case, another challenge came up. Let's say, for instance, this same orange is to be broken into 20. Let us see. For instance, let us assume that 20 persons are to share this orange. Will you still break the orange first into 10 so that the 20 persons can share from the 10? That is impracticable. 20 persons cannot pick from 10 portions. Now that the number of persons that are sharing the orange is above 10, it became a challenge as to what next to do. They now took a different decision. They said, instead of breaking it into 10, let us break it into power of 10, like 100, since the people dividing it or sharing it are more than 10. And we can't share or break it into 10 equal portions. Let us divide it into 100 equal portions. That way, the 20 persons can now pick from 100 portions. We will pick 1, 1, 1, and then 20 will go. Remaining how many? 80. They will pick 1, 1, 1 again into 20. Remaining how many? 60. That's how they keep on picking until each person will get a specified number of portions. When 20 persons share 100 portions, definitely, how many will each person get? Your answer is just as good as mine. In this case, there was no remainder at the end of the process, unlike what happened in the case of 1/7, where the remainder kept taking place until people got tired of sharing in the process of picking from the portions. Now imagine that you are one of the 20 persons that took part in sharing from 100 portions. The first time you picked your own share from 100 portions, what would you call your own share? Obviously, your share is 1/100. Let me help write it. Something similar happens when there are above 100 persons taking part in sharing portions of one thing. What if we have 120 persons to share one thing? Will you still break it into 100? That is impracticable also. The next thing is to divide it into the next power of 10 after 100, which is 1000. Whole number power of 10. Now, if you divide that thing into 1000 and you are one of the 120 persons taking part in the sharing, if you pick your own share, how do you write your share? Obviously, it will be 1 out of 1000. How is it written? Please see it. In this order, we just got 1/1000. In the same order as we got these other ones, 1/1000. We can keep reasoning that way. What if we have number of persons above 1000 dividing something? You can imagine what happens next. I believe that the pattern of reasoning here has become clear to you. We are trying to understand the concept of notations of fractions. That is, different ways people choose to express fractions. So far, from this analysis, something has become clear. What is it? There are two ways that people have chosen to divide one thing before sharing. First method is divide it exactly into number of partakers. Second method is divide it into powers of 10 nearest to number of sharers. I repeat, divide it into powers of 10 nearest to the number of partakers in the sharing. This 1/2 and 1/7 are just two examples. If there are 2 persons sharing, divide it into 2, pick your own. If there are 7 persons sharing, divide it into 7, pick your own. So in this case, This orange, for instance, is broken into 2, and one person picks his own, or into 7, and one person picks his own. So it is either we divide this orange into exactly number of persons that will take part in the sharing, or we break it into 10 and powers of 10, nearer to the number of persons that will take part in the sharing. In fact, let us summarize these two in writing. And here comes a summary. The methods of sharing one item, like this orange for instance. First method could be to divide it into exact number of partakers, that is those taking part in the sharing. Just divide that thing into the number of persons taking part. If 5 persons are sharing in 8, divide it into 5. If 7 persons are taking part in the sharing, divide that into 7. If 9 persons are going to take part in the sharing, divide it into 9 equal portions. That is the first option. Second option is, if it becomes difficult to divide it into the number of persons taking part, simply because the number of persons taking part is odd number like 7 or 9, you just divide it into 10 or powers of 10, according to which one is more practicable. Of all of these things here, all of these fractions, 2 appear to have been done with the first method. 2 persons are taking part, just divide into 2. 7 persons are taking part, divide into 7 and pick your own. But 1, 2, 3 appear to have been done with this second method. This 10 may not be number of persons taking part in the sharing. It could just be for convenience. Even if 7 persons are there to share, first divide into 10, take your own. After each person takes his own, 3 will still remain. Like I said earlier, a different section will be devoted to explaining what happens to those 3 portions that remain afterwards. What about dividing into 1,000, into 100, and into 1,000? The next will be 10,000. The next will be 100,000. The next will be 1 million. So 10, 100, 1,000, 10,000, 100,000, 1 million, and in that order are all called whole number powers of 10. Based on this argument, we are supposed to have 2 names for 2 different kinds of fractions, but we have 3, as we'll see shortly. Why 3 when we have only 2 methods? 3 because in time, people chose 100 out of all the powers of 10 as the most suitable power of 10 to divide things into and to pick from. Based on this, we have 3 different ways people choose to express their fractions, and that will take us to types of fractions or forms in which fractions exist. How many now? I said 3. They appear to be 2, as you can see right now, but they are 3 because of the choice of 100, specially picked out of all the powers of 10. What then are the names of these 3 forms of fractions people choose to use to express? Let them be shown on the screen. Please watch out. And here comes the different forms in which fractions can be written. The first is the vulgar form. What does it mean? It means dividing one thing into the exact number of partakers. Example is 1/2. There are 2 persons to share from 1 orange, and we divide the orange into 2 equal portions. Because of that, because we divide the orange into number of persons that we share from it, we call it the vulgar form of a fraction. The next one is decimal form of fraction. This prefix deci reminds us of 10. Therefore, decimal means picked out of 10, What does it mean? It means dividing into 10 or powers of 10 and then picking from such portions. Don't forget that this 10 may not be the number of persons taking part in sharing it. It is just picked for convenience. Don't forget what was said earlier concerning it. Example is 5 over 10. That is 5 picked out of 10 portions. The third one is percentage form. This root part called cent is reminding us of 100. Pay, it means picked out of. Therefore, if you hear percent, it means picked out of 100. Therefore, percentage form of a fraction simply involves dividing one thing into 100, irrespective of number of partakers. Example is 50 over 100. Because this 50 were picked out of 100, we can also call it 50%. See where it is written, 50%. If it had been 20 picked out of 100, I would have written 20%. So this sign simply reminds us that whatever is here is picked out of 100. So I believe that we can rewrite 15% to appear in this form. Surely, it is going to be 15 over 100. So far, we have three forms in which fractions exist. They are vulgar form, decimal form, and percentage form, which means picking from the exact number of portions that correspond to number of partakers. That's vulgar. Next, picking from 10, which may not correspond to the number of partakers, but for convenience. Percentage, picking from 100, which is 1 out of the powers of 10 chosen as a standard, not minding how many partakers are involved. Notice that 1 over 2, 5 over 10, and 50 over 100 are the same in value. They only differ in form in which they exist. 1 over 2 is vulgar, 5 over 10 is decimal, 50 over 100 is percentage. In time though, a need arose. That need was to rewrite decimals and percentages in forms that could take less space in writing. Vulgar can remain the same way it has remained, but decimal form and percentage form could take different forms. And that now takes us to what we've been talking about, notations of fraction. That is different ways people choose to write fractions. Don't lose track of what we're discussing. These three are only forms in which fractions exist. But next will be different styles, different forms, different ways people choose to express their decimal forms of fractions and percentage forms of fractions. Let's see different forms or different notations of fractions. Fractions corresponding to decimal form and percentage form. Please watch out. Now let us learn different notations of decimal and percentage fractions. That is, different ways people have chosen to write decimal and percentage fractions. Take note of these three fractions here. The first is 1 over 10. What type of fraction is that? In what form is it? Is it vulgar, decimal, or percent? Obviously, this is in decimal form. What about this one? 12 over 100. Is it vulgar, decimal, or percent? It is percent. What about 25 over 1000? Is it vulgar, decimal, or percent? It is decimal. Don't forget that even percent is a special type of decimal fraction. The reason is that decimal fraction simply means breaking one item into 10 and whole number powers of 10 and sharing from such portions. 100 is a power of 10. 1000 is a power of 10. But in this case, 100 earned itself a special position and became known as percent. Therefore, that we have 12 over 100, calling it 12% here, does not change it from being decimal. In fact, all the three are decimal fractions, but this number 2 has a special name, which is percent, for being picked out of 100. So this is one way people can choose to write their decimal fractions. But we have simpler ways of expressing each of these things. How? Find out what happens next. Yes, these are other ways we can write these fractions. Don't forget that they are all decimal. This alone is percentage, which is a special type of decimal fraction. First, if you want to write 1 over 10, that is 1 taken out of 10, it is either this way or this way. If you want to write 12 picked out of 100, it is either written this way or this way. If you want to write 25 picked out of 1000, it is this way or this way. Now, with these forms or notations of decimal and percentage fractions, you may not be confused. But with these latest forms or notations, you might be asking, what informed writing this in this form, this in this form, and this in this form? How were they obtained? Anyway, it is important that you learn that this was chosen just as a way of simplifying these expressions. To get to understand these things, watch this 1 over 10 and watch 0.1. This 1 alone appears here. This 12 alone appears here. 100 disappeared. 10 disappeared. Also, 25 alone appears here. This 1000 disappeared. Disappearance of these 10, 100, and 1000 is that method of simplifying the decimal and percentage forms of numbers to take these forms. Before you make conclusions as to how these things became these ones, I ask, which one takes more space between this and this? Surely this takes more space. That means some people choose and chose. So some people chose in the past and still choose today to write it in this form. People chose to write this in this form, and today people still choose that. People chose to write this in this form, and till today people still choose that. Why? These notations take less space and time to write. Then back to my question, how did this come to be this? It was done by convention. It was just agreed that this 10 can disappear and 1 alone will appear. But something must inform us of this 10. 1 was picked out of 10 and 1 is alone here without 10 with it. How then do we know from how many portions this 1 was picked? Only 12 exist here. How then do we know from how many portions these 12 were picked? 25 alone is here. How then do we know how many portions from which 25 were picked? Now watch out. This dot separates a whole number from a fraction. Whatever you see here is something that a share that was gotten. That share is not a portion. It is one whole thing. 0 means there is no one whole thing. Even if I remove this 0 and write only dot 1, it is still correct. If this 0 is removed and I write only dot 1, 2, it is still correct. If 0 is here or not here, this expression is still correct as long as dot is there. This dot was chosen to signal that whatever follows is a portion picked out of portions. Therefore, a dot is here. That means whatever follows the dot tells us how many portions picked out of some portions. So far, it is one portion picked out of how many? 10. How many zeros are in 10? Just 1 0. How many digits are there from point towards the right? Just 1. Now, keep this result. Move to the second one. From this point, please, from how many portions were 12 picked? 12 were picked from 100. Come again to this notation. From point, after this point, towards the left, towards the right place, how many digits are written? 2. 2 zeros in 100, 2 digits in this notation. 1 0 in 10, 1 digit in this notation. 3 zeros in 1000, 3 digits in this notation. Is a pattern developing? Yes. And that pattern is exactly the most important thing you should learn about expressing decimal fractions in this notation. At this point, we can make a summary or a conclusion as to how to write a decimal form of a number in this form. Let us see. And here is the summary of how to do that. It says, to rewrite a bar notation in dot notation, write only the numerator after the dot and let the number of digits after the dot equal the number of zeros in the corresponding power 10 denominator. This is a long instruction. I just hope you understood what was said here. To make it easy to understand, let's get back to what we did before. This is a bar notation, and this is a dot notation. This is a bar notation. This is a dot notation. This is a bar notation, and this is a corresponding dot notation. What it means is that to have a bar notation and dot notation for all decimal and percentage fractions. Now, it says to rewrite a bar notation, that is to write this in this form. What will you do? Write only the numerator. Okay, this is my numerator. See it here. Written when and where? After the dot. See my dot here, which I placed. So 1 was written, that is this numerator, which is 1, was written just after this dot. And what is next? Let the number of digits, where? In this dot form, after the dot, let the number of digits that come from this dot onwards be equal to number of zeros in this power 10 denominator. This is our power 10 denominator. How many zeros are here? Only 1 0. How many digits are here from after the point? Just 1. Therefore, the number of digits has become equal to the number of zeros in the power 10 denominator. The same thing happened here. To rewrite, write only the numerator. Yes, I picked 12 here. See it's this place. Next, it should be written after the dot. This is my dot, and 12 came after it. And what is next? Count how many zeros in this denominator. There are 2. Because there are 2, there should be 2 digits towards the right after this dot. And here there are 2 of them. Therefore, this was correctly expressed from here. This is a bar form, and this is a corresponding dot form. The same thing happened here. But that is something that we have to learn more about how this became this. If you watch this, you discover that 0 was used to complete it into 3 digits. If you just write 25 alone and put dot just before 25, it will be as if 25 were picked out of 100. But here, in actual sense, 25 were picked out of 1000. So first, write 25 after a dot. If you count the number of digits from this dot towards the right and there are 2, yet we have 3 here, that is now a problem. There is inequality between number of zeros in this denominator and the number of digits from this dot towards the right. To equate them, 0 was invented, and this was done by convention. Therefore, this 0 is doing nothing but just to tell us that there are 3 digits. Without it, there will be 2 digits. Therefore, we can complete the number of digits required to equate the power 10 denominator by using 0 as it is used in this number 3 example. I just hope that what has gone on here is clear. Therefore, 0.1 means 1 picked out of 10. 0.12 means 12 picked out of 100. 0.025 means 25 picked out of 1,000. So far, it is understood, I believe. Now, watch out for an exercise. And here comes the checkpoint. It says, rewrite the following decimal fractions from bar to dot notation. I just hope you understand the instruction. Number 1 says 3 over 10. Number 2 is 5 over 100. Number 3 is 1 over 100. Number 4 is 15 over 100. Number 5 is 18 over 1000. And number 6 is 7 over 10,000.